And then it should have
Oh, shit.
roughly x-axis where the earth is.
Because the slope will go around the line.
Oh.
So it's gonna be like,
Yeah, I think it actually has two now.
I think you should like know the points where the slope equals zero, because that's when it's gonna cross over. So here it'll cross over.
One big on the left. And then, oh, you like horizontal.
Yeah.
I'm saying it wrong.
I was so
Right
confused.
in the middle where it has like a constant slope.
Yeah, that's just like
So it's just
one
straight
straight
line
line.
there.
And then a bit down, flat line.
Yeah.
I was so confused because you were like.
Yeah, no, I misspoke. Yeah. Yeah, it has two horizontal.
No, I think this, that, I feel like the first question is, because they're like, there and there, and that,
Oh, and at that point, at those 2 points, like at the end of the line, it's undefined because
like in an equation.
you can't find out what it is. It's like calls it.
And then
Yeah.
you get that square.
The derivative of parabola will be like 2 So that's like a line, so it'd be, it's gonna be a line. I think it's positive. And then it like it's undefined.
The third.
Oh, wait, no, it's
It's like the
negative.
equation.
It feels
That's from the equation for what? Oh, I'm recording.
Oh, yeah, the slope should be like negative, yeah.
Where is yours? Okay, thank you. Sorry.
No way. Like just like X, so. Negative.
Oh, for the equation.
Yeah.
Zero gets
And then I can find
for a little bit,
the
and then it's
derivative
undefined.
and
Yeah.
understand it. Because I don't
So
understand
it's just like 2x. So it's just the line.
Well, because there's also like the plus something.
No, it would be, yeah, but that doesn't matter for us.
Yeah, so it's just like kind of.
Although that matches derivatives, yeah. Oh, no, wait, yeah.
Like,
That's what I was trying to get.
Oh, so it's 2x minus 4.
Because it's just a straight line.
Yeah, it's 2x minus
Like, because the derivative of x squared is like, or is negative log of
Well, minus 4 means the y-intercept.
It gets to that line, like after it goes here, the slope.
But the line starts like there.
So like, if we're graphing, I also think there's like, then it's gonna be negative versus here.
It's weird.
You get what I'm saying?
Like the derivative of x.
I'm not sure what the I think she's like.
What is kind of like
The slope is still down. If you took the double derivative, and it'll be the down there, but it's it'd be like,
Wait a minute, this, that.
because if you change the derivative, slope, it is going down.
You have to show them more inspiration. It's a bad thing.
Yeah, it's open. Because it's undefined.
Wait, I think just make sure you draw in white circles like there. So show that it's high.
oh yeah.
Not a point.
Oh yeah, no, that's just to like help you.
It's
Oh,
go
wait, yeah, so I think the line just
not
goes up like
part of
that.
I think it's just literally one line. Like, I don't think it splits out.
Yeah.
Yeah.
Okay,
like that.
so looking around the room,
So then it would be like
I saw
this wouldn't it? Something.
things like this,
Oh wait, no, it's a negative.
and I
Yeah.
saw, um, and I
saw something more like a W with open circles. And there was a lot of conversation with valid statements. I heard people say, no, wait. Horizontal tangents, the derivative's going to have a 0. It's going to hit 0 there. I agree. Horizontal tangent, it's going to hit there. And when we were doing the matching thing with the Dutch program that was dark blue and red on top of each other, it's hard to see. You guys were already doing power rule without having been taught it yet. This thing looks like a negative quadratic, so it's going to be a negative straight line. But today you weren't remembering that. You were like, well, wait. The slope is positive, positive, positive. Then it tapers down and goes to 0, and then the slope comes negative. And that's what caused some of you were kind of making this line curvy because you're like, well, it's less and then it's more, but it's going to be a straight line. The slope of any straight line is the coefficient. It is the slope, right? It's how many up, how many over. It's a constant. You had the choice of where you wanted to put it, but it's some flat positive line. So this part is looking good, this part is looking good, that part was looking good. Then here, positive quadratic is going to go to becoming a positive straight line. So this was a test question, and the things that I needed to see that were correct, that the zeros were right, that line was horizontal, and it was positive, could have been anywhere there, that this straight line on the left had a negative slope, any kind of negative slope, because how are you going to gauge how steep that is? And then the second piece had also a positive slope, and it hit the 0 in the right place. Yeah?
And points of the graph are also open circles?
So I would say you're safer to leave them open. If you close them, I wouldn't mark off. Definitely in the middle, they need to be open circles. But at the beginning, like, if this was speed, I mean, it doesn't actually make sense as speed, but you're in the starting blocks, gun goes off, and you go to push off. What is your speed right when the gun goes off? You're going from 0 to 60 in a split second. Like, what's your speed right then? I don't know. It makes more sense to me to leave it open. Any other questions about this? Okay. So today we are doing 3.4, which is kind of in context derivatives. The homework is out of the textbook, which if you want to take pictures at the end of class, sorry that I don't have them posted anymore. The textbook I had, the link is dead. Larger than life. Rates of change. Okay. Given the area of a circle's formula is pi r squared, find a formula for the rate of change of the area with respect to the radius. And what would that rate of change be when the radius is 4? 16 pi? What is the answer to A?
2 pi r,
What's on the other side?
dA over dt.
Almost.
d over
I don't have time in there anyway.
dr.
Okay, this is why the physics teacher is like, you math people, you need to fix that. Trying. So how does the area change as the radius is changing? Multiply by the power of the changing radius, lower the power of the changing radius. Interesting that the derivative of area is circumference. And then notation-wise, the area is getting 8 pi bigger. Don't know what unit, so I'm not going to make any up. When radius is 4, whatever units it is. Yeah? Good. Questions? Okay. Jumping through some of these. I don't know why, again, I said this yesterday. I don't know why they use S for position. But what is your change in position over time? Velocity? So the first derivative of position is velocity. What's the second derivative of position?
Acceleration.
And physics friends and pre-cal people, velocity is a vector. It has a magnitude, a strength, and a direction. Speed is just the magnitude. So for what we're doing right now, it's like, so what? If you were going backwards 500 miles an hour, your speed is positive 500. When we get to chapter 10, which includes vectors, this will actually mean, those little bars will mean magnitude, find the length of that vector. How long is it? But for now, it's not so challenging. Okay, as we just said, derivative of position is velocity, derivative of velocity is acceleration. And gravity, you don't need to know it, but English units, and these should be negative 32 feet per second versus negative 9.8 meters squared per second, or per second squared. Without a calculator, can use calculus to figure out how high an object would be. Like, talk to each other and figure out how can you do that without calculus.
Just taking the minus 30. But I was like, that should tell me 0.
Without a calculator, but using calculus.
You just take the derivatives, and then when the velocity is 0.
I'm not sure how you actually get to.
Well, because it's 16, it's like 16 times 2.
Got any clue?
Well, I know it's 20 because you said using calculus, but I don't actually know what you do after this case. Say that.
I feel like it's like, I feel like it's
Okay, so here's our object. Ready? You gonna catch? Catch. So what happened? Throw back. You gotta give it more of a projectile, like
Oh, my bad.
more of an arc. So as we're tossing the thing, whoop, the position's changing. It stops going up and starts coming down when?
At the top of the arc.
At the top of the arc, what's the velocity when it's going up?
Oh, 0.
When it's
Velocity
going
when
up.
it's going up is positive, the velocity when
At
it's
the
coming
top it's 0.
at
Oh,
the
yeah,
top
yeah.
it's 0. So what are you gonna do?
You find
Find the
it's
derivative
0.
of the function, just give it
Oh,
velocity,
okay.
you said the velocity goes to 0, then you solve for t.
Okay, you do all the things that he just said.
Yeah.
Don't take anything out.
So it's just what you do.
It's just this, yeah, it's just the calculus version. I know how to take the pre-calc.
So it's about like 5.
Yeah.
This 160 or 16 is
Yeah,
x.
that might be
No, yeah.
So
no,
160
no.
over 32 is 5.
Okay.
Square, you get the derivative.
Yeah.
I got t equals 5, am I done?
No.
Okay, Andy's like showing the whiteboard like, no, you didn't finish the question. That's a big problem in AP calculus. You guys are like, it's so much work to get to the actual answer, you stop halfway through because you're like, I did all this work, I gotta be done. I did the derivative to find the velocity. Why? Well, because when velocity changes sign from positive to negative, when it's 0, that's when that projectile is gonna start coming down. So I found what time it is, and Andy's like, you need to go back to the position function up here, plug in that time, and he's waving the whiteboard that says 400 feet. Questions on that?
We got 400.
And you're all very clever, and people were like, well, I'm just gonna find the vertex of where that parabola turns around. Yeah, okay. Yes, that works. Negative b over 2a. How about that one? What is the speed and velocity, so two different quantities that I'm asking for, when the height is 256 feet high?
Oh, yeah.
How you doing? Okay, I mean, did you catch up on the things that we did the last 2 days?
Yeah.
So you're okay with quotient rule and product rule? So I found, when is the position 256? You gotta remember algebra? Oh, come on. Awesome. Love how this board works. So I moved everything to one side, factored out the 16 to make it smaller, and I got 2 and 8. Milo, are those my answers? No. What do I need to do?
Derivative. Or something, find the speed.
Okay, so I have the derivative. So plugging in to velocity, v of 2. This one I was given units, so I'm going to keep them. Velocity at 2 is positive 96 feet per second. Velocity at 8 is negative 96 feet per second. What is the speed?
96 feet.
Both of them are 96. So if you were the little bug on the projectile, you don't care that you're screaming up at 96 feet per second or down at 96 feet per second, just that you're like, "Wah! We're going this fast." Find the acceleration at time 3. So what's the acceleration?
Negative 32 feet per second squared.
Negative 32 feet per second squared. What is it at time 3?
Still negative 32.
Still negative 32. Like, doesn't matter what time it is, gravity is a constant. So the double derivative of position is the first derivative of acceleration or velocity, which is acceleration, which negative 32 feet per second squared at time 3, at time 20, at all time. Good? Meh. When does the object hit the ground? So Lily, what was, you just had a, oh yeah, look, what,
Oh, no, I was,
no? Constitute?
Would be 10 seconds,
Be 10 seconds. Why is it 10 seconds?
because it's like a parabola, so it gets to the vertex after 5 seconds, so after another 5 seconds it would be at,
Okay, so there's a symmetry in it. I'm gonna kick it old school and be like, well, when is the position function 0? I'm gonna factor out 16t. So at time 0 and time 10, and because we know what the parabola looks like, at time 0 is when it was taking off the ground, and at time 10 is when it landed on the ground. What is the velocity then? Okay, here's my velocity equation. Plugging in looks like negative 160 feet per second is when it comes screaming to the ground. Okay? All right, don't write anything. This is just a picture in your book. The goal eventually is that you'll be able to look at a position graph and know what's going on. So right there, if This is distance from home, we started at home, and this is time. Are we walking away from home, towards home, or are we standing still?
Oh, yeah, wait.
Walking away from home. Are we walking away speeding up? Are we getting faster? Are we walking away at a constant rate? Like what? I'm walking away at a constant rate? How can you tell?
Same slope.
The slope of the line is my velocity. The slope that right there looks kind of straight. So if it was a slope of a half, it looks like a constant rate to me. What's happening right here? Stopped? Am I going towards home or am I neither? Okay. What about right here?
Back towards home.
Going back towards home. So right here, I'm like, okay, I've decided I gotta go back home. So right there, I stopped going away and started coming back. What's happening right here?
Moving down, just doing right there. Stop again.
I'm standing still. Did I make it home?
No.
No. I'm reaching distance, but I'm not home. So with calculus, we're going to be doing all these derivatives to be able to tell us, am I going faster? Am I going slower? Am I speeding up? Am I slowing down? We're gonna get to all of that stuff. So we will see how far we get through this. You'll need a calculator or some device that can do stuff. So see what you get. When is the particle in reverse direction? How would you find total distance? And that last question, speeding up, slowing down, there's a lot of conversation to be had for that. Let's give it a go. You might want to graph it. Like, you can use a calculator so you can get a look at what it's doing. It might be helpful.
I have a question.
Yep,
If we can, actually, wait, never mind.
good talk. You guys got answers to the first one? Can you write them on the whiteboard so we can compare? And I also want to make sure that you get the answer to the right number of decimals. What is the right number of decimals? 3. Don't say it with a question mark. Always and forever, 3. They don't care about significant figures. They don't care about the context of the question. 5.721 people.
Just give me the answer.
So what'd you guys get as the zeros? Anything written on the board? Yep.
Will they, on every calculator test, will we be able to use it?
Probably. There are other answers? 0.7. Okay, so, one thing, no hats, no hats, no hats. Another thing, this is 3 numbers, but it's not 3 decimals. Same with this one, it's missing a decimal. I would take those 2. AP, you can also truncate. Does anybody know what truncate means? It means just cut it off. So I could also, like on my answer keys, when rounding, it can go either way. I would also accept 2.059 or 2.060. But 2.06, they do not give you the point. Truncating, they would accept 0.606, or properly rounding, they would accept 0.607. 0.609, no, and no hats, no hats. Okay, right here, do I know that the object turns around at these spots? Okay. I know that velocity hits 0 there. Whenever velocity is 0, do you have to turn around? So come up to the stop sign, wait. Normally I would go forward. The number of times I've slammed my car in reverse and been like, I'm just kidding, would be 0. So, number line test. Name your number line. What are you testing? I'm testing my velocity, my change in position. And I'm gonna put, sorry, I abbreviated them. I did just put a single decimal here because I was too dirty with all the extra numbers. But testing like at 0.1, putting that in here, I got a positive. This is a calculator question. You could have also just looked at the graph and saw that the parabola was positive and negative. Hello, come on. Ooh, interesting. Okay, so it was positive here and there and negative in between. Okay, now I know the velocity changed sign. So in the land of having to justify, because velocity went from, I was going forward to going negative velocity back to going forward. Each time I changed the sign of my velocity, I changed direction. And long live Jonah. If it's vertical traveling, which way is the positive velocity, up or down? Up, okay, because the y values on the graph go up. Okay, if it's left and right, the positive direction is
Right.
to the right? Okay. Jonah argued with me for a long time that that was not obvious. Okay. I will forever now define it. So, and I didn't ask this in here, but the particle, whatever it is moving to the right till 0.6 seconds, and then it's moving left till 2.060 seconds, and then to the right again from then on out. How am I gonna find the total distance traveled? Like without a whole lot of calculus yet? Yeah.
Take your initial and add it to your final.
Okay, so here's my initial position. I went forward, and then backwards, and then forward again. If I take my initial and my final, that's displacement. Is that the same as distance traveled? Okay, so like if I run around the track, absolutely hate running, especially hate running around a track. You go around and around and around, and you end up where you started. And if my Fitbit doesn't credit me for like actually doing those 2 miles, I get really, really cranky. So displacement was 0, but my total distance traveled was 2 miles. How am I gonna find, like, it's calculation-wise a pain. What do you think?
Like absolute value. I'll
Okay.
figure out when velocity's positive, and then, well, can you integrate or not yet?
Nope, we don't have to integrate yet. This is why I'm saying, I know what you, yes, and we're not allowed to do that yet. What do you think?
You can find like the displacement of all the places where it like goes, where it turns around, and then add them together.
Find the displacement of every thinking one. So from the starting block, add 0 to 0.606. How far did you go? So I started at 0, and at 0.606 before I turned around, I was at 4.1044, no units. So from 0 to 0.606 seconds, I went 4.1044. And then I turned around, so now I gotta do the displacement between those two zeros. And then from when I turned around again, and then add them all together. Yes, displacement, displacement, displacement. Okay, the speeding up and slowing down, that was a much harder question than I intended to be on here, but it's here. Hello, change. Thank you. If this is my velocity, where is it speeding up?
Like, the positive slopes?
The positive slopes, so I'm speeding up here and here?
No, sorry. The first positive slope and then the second negative, like when it crosses the x-axis, that's when it's speeding up.
What do you think? He says, we're speeding up here, velocity was 0, then 1, then 2, then 3. And then he said, no, not everywhere that the slope is positive, but, okay. And that's speeding up too because I was running away at 1 per second, 2 per second, 3 per second, okay. So slowing down is here and there. Is there something we could, like a mathematic rule that we can make so that we can say, without looking at a graph, I know that we'll be speeding up at this time. So here the velocity was positive, here the velocity was negative, so it's not just looking at velocity. Yeah?
Would you like find the acceleration?
Okay, what would that tell us?
That'll tell you where you're speeding up and slowing down, right?
Well, here, how do I read the acceleration off a velocity graph?
Well, in that one, it'd just be like a flat line.
Okay, positive or negative or zero?
It'd be a positive flat line.
Positive flat line, so I'm looking at the slope of the line.
Yeah.
Okay, so here velocity is positive and the slope of this line is positive. Here velocity is negative and the slope of velocity is negative. Okay. Do I have a rule yet? Velocity was positive. Okay, positive velocity, positive acceleration, positive velocity, negative slope to velocity, so negative velocity, negative acceleration, negative velocity, positive acceleration. What do you notice?
It was the same sign, or like, then it's, speeding up, and if they're different signs, then they're slowing down.
So if velocity and acceleration are going the same direction, they're vectors, they go the same direction, then you're speeding up. If velocity and acceleration have opposite signs, you're slowing down. Okay? Please do the homework tonight and be careful. What did they give you? This one is a position graph. This one is velocity. This, yeah. Be careful.